Chapter 4, Lesson 1, Graphing Equations in Slope-Intercept Form. So the first thing we need to know is, what is slope-intercept form? Slope-intercept form is that equation that says y equals mx plus b. All right? And in slope-intercept form, the m represents our slope, and the b represents the y-intercept. All right, now, when we want to write an equation in slope-intercept form, there's two pieces of information we need to know. We need to know those m and the b. So we need to know the slope. That's very important. And we need to know the y-intercept. So we need to know what's that point that the line crosses the y-axis. Remember, the vertical axis. So if I'm just given the slope and the y-intercept, it's pretty easy to write an equation. So I have to write an equation that has a slope of 3/4 and a y-intercept of -2. I'm going to use that equation, y equals mx plus b, and I'm going to say, okay, my y never is going to be replaced with a number. So y equals, and m is 3/4, and it's going to be times x. And then instead of putting plus -2, I'm just going to put -2. So there's my equation, y equals 3/4 x minus 2. Now, if we're given an equation and we're asked to write it in slope-intercept form, my goal is that I want it to look like y equals mx plus b. So the first thing that I need to do is try to get that y all by itself. So if I look at the first equation, I say, well, I'm multiplying it by 2, and I'm also subtracting 5x from it. First thing I want to do is get rid of that 5x by adding 5x to both sides, and that cancels that out. I'm left with 2y. This is where we want to be careful. We want to make sure that we write those terms in the right order. I want to write the term with the x first, so I'm going to write 5x and then plus 4 because it's a positive 4. Now I'm going to divide everything by 2, and this is where it gets a little bit tricky. Okay? I have to divide this term by 2 and this term by 2. So I'm left with 5/2 x plus 2. Because I divided the 5 by 2 and then the 4 by 2. Okay, and over here I'm going to first get rid of this 6x by subtracting 6x. Now be careful, that leaves me with negative y. And I'm going to write this in the right order, negative 6x plus 4. But now I have a negative y, so I'm going to change the sign of everything. It's going to become y equals 6x minus 4. And now my equation is in slope-intercept form. That line has a slope of 6 and a y-intercept of -4. All right? Now, a couple things to remember, especially when we're converting those equations, is that our slope can either be a whole number, like 6 or -2 or 18, or our slope can be a fraction, okay, like 1/2 or 5/2 or 2/3 or -8/5. It is never going to be, we never want to change it into a decimal or a mixed number. Those are kind of no-nos when it comes to our slope. Now, the y-intercept can be a whole number, it can be a fraction, it can be a decimal, it can be a mixed number, it can be just about, we can write it in any form that we want to. So sometimes our slope might end up, like on the last one, it was 5/2. I don't want to change that to 2.5 or 2.5. All right, now if I need to write an equation from a graph, remember, what is it that we need? We need the slope, and then we need the y-intercept. So for me, when I'm looking at a graph, the y-intercept is really easy to see. Right? It's right here at -1. So my y-intercept is -1. My slope is a little bit harder. Not hard, but I have to count it. So again, find 2 points that you can count it from. The y-intercept is usually a good one. And then I can count. It goes up 3 and over 1. So my slope is 3/1. Now when I write that in my equation, I want to write that as 3. So my equation is y equals mx plus b. So y equals 3x minus 1 is my equation. All right, now, how do I graph an equation when I'm given the equation in slope-intercept form? Well, the first thing I'm going to do is I'm going to plot a point for the y-intercept. It's pretty easy. I just look at that number that this is the b, and I put a dot there. And then the second thing I'm going to do is I'm going to count the slope. Now, this is what's important, from the y-intercept. So I'm going to plot that one point, and then I'm going to start counting my slope, rise over run, from that point that I just plotted. All right, now, if my slope is positive, I have two different ways that I can count it. So let's say my slope is 2/3, for example. I can either count it as rise over run, 2 over 3, or I can count it as rise -2, run -3, because remember, a negative over a negative also equals a positive. If my slope is negative, let's say it's -2/3, I can either count it as -2 over 3 or 2 over -3. It's either negative over positive or positive over negative. All right, now if the b is 0, that means that the y-intercept is 0. That means it passes through the origin. And that's okay. Our b can be 0. Now if our m is 0, this is where it's going to look a little weird, because if I have y equals 0x plus 2, I'm not even going to write this. It's going to be y equals 2. So if my m is 0, it means that I have no slope, and it's going to be a horizontal line. All right, now let's graph an example. If I have 2x minus y equals 2, first thing I want to do is get it in slope-intercept form. So 2x minus y equals 2. I'm going to subtract 2x on both sides. Negative y equals negative 2x plus 2. Change all the signs. Y equals 2x minus 2. First step, plot that y-intercept. So I'm going to go down to -2, and I'm going to put my first dot. And then I have a slope of 2. So I'm going to count it rise over run, 2 over 1, or -2 over -1. So I'm going to count it the first way. Up 2, to the right 1, put a point. Now I'll show you how I also could have counted it the other way. I go rise -2 and run -1 and put another dot. And then I draw my line. And there's the graph of that equation. All right, let's do another one. Y equals 2x. So it's already in slope-intercept form, but there's no b value. That means it goes right through the origin, and I have a slope of 2, just like I had before. So 2 over 1, or -2 over -1. So I can go up 2, to the right 1, and there's my line. Now, two things to remember. We have some equations that we call our constant functions. Constant functions are when we just have like y equals 8 or x equals 4. All right? If you have y equals a number, you're going to look at your graph and you're going to go on the y-axis and you're going to put a dot at 8, and that is going to be a horizontal line. So if it's y equals something, it's horizontal. And if it's x equals something, you're going to put on the dot on the x-axis at 4. And then you're going to have a vertical line right there at 4. So it will be vertical, so it has an undefined slope.